So this is my solar well pump project. So I got a, let's see what we got here. Got a protective fence to keep the livestock out of the equipment area. I just used some T-posts and cattle panels because they're structurally pretty stable. Then we got our 5,000 watt generator here, and that powers the, well, I guess I should say we got two well pumps and one 6-inch case. So the lower pump line right there, let's see right here, that's a 220 volt AC, I believe it's a 2 horsepower pump. It does about 11 gallons a minute. And then we got a Grundfos solar well pump on the other side. And I modified the well cap to accommodate the conduit that shares, both well pumps share the conduit together. Come through here and then up into this junction box where it diverts to the 220 volt system, AC system. So we got the disconnect and a pump saver, a pump controller, and then up here we have the solar well pump system, the conduit that comes in here. This is the main shutoff. It's a transfer switch also. It's so I can run the solar well pump off of a, I think you could do like a 800 watt generator. That's all it really needs, because it only consumes about 670 watts to pump water from the smaller solar well pump. But here's the main switch, and then we got this control panel here. This is also to do the float control. So right now the tank is full, so the light is on, so we're not pumping any water right now. Let's see, I could probably do an override here. Let's see what will happen. Solar panels are in the shade right now, but we can see what happens here. See if it produces anything. Doesn't look like it. Yeah, it's too shady over there. So there's nothing to pump. And basically this controller, it's got a float control here, on off switch, and then it gives you the wattage. Lets you know if your pump's running normal at maximum at noon, when it should be pumping at maximum. And then it's got an indicator here for if your well is out of water. There's a safety inside the pump, and it indicates here with a light. And then also if something's wrong with your pump and it needs service, there's a light here. And then I used there it just told me again, the controller just said the tank is full, so it's not pumping anything. So here we have the Smart Water wireless pump controller. This controls the float system wirelessly. I had to add a small electrical system here to be able to basically use this controller. So I had to add a small AGM battery here, and charge controller for this small electrical system, and a 12 volt relay. Let's see if it'll focus. So basically how this works is this controller has a 24 volt DC line out that is supposed to go for like a float to a tank that's nearby. But my tank is like 2,000 feet away, so I can't run 24 volts DC all the way up to my tank. So I went wireless. This wireless controller is set up to run an actual 12 volt DC pump directly through it. But that's not what we're doing. We're running a solar well pump. So basically what I had to do is have a small 12 volt system that powers the wireless controller and has a relay. So when the controller tells the relay that to pump or not to pump, then there's a switch inside the relay that connects for the float control. So that's how I had to wire that up. And since I had a small 12 volt system down here, and I had a 12 volt compact fluorescent light that was just sitting around, I just added a little light switch here, so in case you're here at night, you need some extra lighting. And I got this is just a 30 watt monocrystalline solar panel from like Amazon. It's like $80 or something. That goes to just charge that system for the solar, the wireless controller. And so that's basically it. And my solar panels are located about 350 feet that direction. Right now the sun is set back over there, so there's no sun hitting the panels anymore. And I did that because this location, the sun, right now we're near winter solstice, and the sun barely arcs up above these mountains. And I got all these trees here, and I got this giant sycamore here, and a big white oak here. So I used an app called Sun Surveyor and came up with the best location that was feasible over there, where we get a lot more sun hours. And that's it for the solar well pump. And next I'll go up to the solar panel rack, to the array I installed for this. So here we are at the solar array. This is the array that powers the Grundfos solar well pump. Again, I got the cattle panels with T-posts for protection from livestock. This array is 1,000 watts, and this produces more than enough power to run the well pump. The pump uses about like 670 watts maximum. And so basically, if the conditions are not optimal, or if the angle is not optimal, this array produces more than enough, and the pump only uses what it needs. Or if the panels are dirty and they're not producing optimally, the pump will still have plenty of power accessible from the panels. So I went with the ZoneWorks passive solar tracker. I think it's a UT72 tracker. It uses like some type of refrigerant in the end cylinders with the chrome plated like plates that direct the sun, and when the refrigerant is heated to one side or the other, it'll transfer fluid and then act like a counterbalancing weight to rotate and track the sun. And so you can see here, they call this this black part hanging down on the, I guess it'd be the west side, is a wake up plate. So when the sun sets to the west, it stays to the west, and then the sun rises in the east and it hits this plate and gets it to start to rotate to the east. Right now we're at like winter solstice, like I said, So I just have it strapped down like a normal array at 35 degrees. It just doesn't get enough sun to really want to rotate right now. And so instead of putting a bunch of wear and tear on the bearings and stuff, I just isolated it with some straps. It's a passive system, so it doesn't matter. There's no mechanical, parts or gears or motors that are going to break if I strap it down. Keep it from rotating. So here, let's see, what panels do we have here? These are sun module, Solar World, 275 watts. But you derate them, you lose like 10%, so really this array only produces about 1,000 watts. And let's see, here we got the breaker. I got it labeled, and then so people can, if someone comes here and they don't know what this is, they can understand how this system works. We have a lightning arrestor and a ground rod, and all the panels are grounded together with copper wire. And I guess that's about it for this. This thing was working really great this summer. Watching it rotate passively. Let's see. Doesn't track rack. Okay, and then I added some labeling up here for different degrees of rotation for the sun during different times of the year. And this has a full adjustment here. And also just some labeling for maintenance, the grease, the bearings twice per year. There's one bearing down here and then one up there. And they call this these storm collars. Let's see, it's not coming up too good, but basically in case there is a storm with heavy winds, so they don't damage your array in the system, you can just use these ratchet straps and strap it down. Keep it from flying around in the wind. I think that's it for the system here.